Hello, this is a random engineer, and what we've got here today is the 1KCube. The 1KCube is supposed to be a CubeSat that can be built for under $1,000. So let's dive in a little bit. So first question some of you probably have is, what is a CubeSat? Well, CubeSat at its most basic conforms to the Cal Poly CubeSat specifications. Yeah, I know, it's a really great answer. It's a 10 centimeter by 10 centimeter by 10 centimeter cube, and this is what we call a 1U cube. The image here you can see of the NCube 2, which is a Norwegian CubeSat. It's a pretty good example of a 1U cube. You can actually stack this 1U size on top of each other to form 2U and 3U respectively. So they become 10 centimeters by 10 centimeters by 20 or 30 centimeters. For a 1U cube, its mass is also, most schools, most people that I've seen aim for about 1 kilogram. I think 1.33 is the max allowed. And they're typically designed for a standard P-pod launcher, which was also created by Cal Poly as part of their specs. So why should you care about CubeSats? Well, first thing is space is awesome. I think we can all agree on that. And that building things that go into space is cool. But in all seriousness, CubeSats can be a gateway for engineering students. I know that I worked on a CubeSat project back in college, and it was a very, very good experience for me. I learned a lot, not only in my field and in my major, but I learned a lot about how to deal with other people and how to work on teams and how to communicate effectively, especially in an engineering field, in an engineering environment, which is something that not all students can get a lot of experience in school. It's also a multidiscipline project, so at the end of this there will be electrical, mechanical, software, and systems components, all that have to work together to make sure this comes out and it works correctly. Hopefully that makes you want to care. So yeah, why the $1,000 number? Why not? It's a nice round number. For the most part, it's reasonable for the serious hobbyist, so anyone out there who hacks on a respectable budget might decide they want to build one of these, and why not? There are actually really low-cost launch opportunities. There are even some free launch opportunities available. So it's not, it's feasible for somebody in their basement or garage to put one of these together and actually launch it. It's one of the reasons the pocket cubes have become so common and so interesting, is they're much lower cost and much easier and much cheaper to launch. The $1,000 is also a good number for educational institutions. I know that the project I worked on, I think we had a budget of around $5,000 for a year, a 3-semester school year. And that's really not that much, especially when you consider that for a lot of systems, for a lot of these CubeSat systems, the solar cells alone will cost you $3,000 for a set, for a cube, for a single set. That's without any spares. So if we can get this down to around $1,000, it makes it really affordable for educational institutions. So what all goes into a CubeSat? Well, it's actually pretty simple. You've got a structure, you've got a power system, you've got a comm system, you've got a command and data handling or some kind of computer system, and you should have a payload. At least I would hope if you're going to go through this much effort, you're going to fly some kind of payload. Be it an actual space science experiment or even if it's just a camera. Yeah, and that's pretty much it. That's all there is to a CubeSat. They're really not that complicated. So if you dig down a little more into the layers of a CubeSat, you'll see here a pretty good breakdown of what we've got. You've got a solar array. You use to pull energy from the sun. It dumps into your power system. Usually it's going to consist of some kind of charge circuit and some kind of regulator circuits. You also have a battery connection that you'll use to keep your cube running when you're out of the sun. So don't always assume that just because you're in space you're always going to see the sun. Good portion of your orbit's going to be spent on the dark side, at which point you've got to have enough battery backup to keep yourself up and running, or else you're just going to shut off, which can be an option. I have seen cubes fly like that, where they only operate when they're in sunlight. Typically this is going to connect to some kind of system interface, and then your payload, your CNDH system, and your comm system are going to interface with that same system interface. And it's all wrapped up with a tidy little structure system. So looking at this, we need to figure out where can we cut the costs, because I mean that's really what we're aiming for here, is a CubeSat system that's cheap and that can be easily replicated by most anybody out there. We don't want somebody to have a PhD to build this thing. They need to be able to build it using the tools that most people are going to have available. So soldering irons, oscopes, multimeters, benchtop power supplies, that kind of stuff. So where can we cut the costs? Just about everywhere, actually. We're going to try and use the advancements in open source hardware and open source software to lower the BOM cost on the electrical systems, so COM, CNDH, and the power system. We also want to utilize rapid prototyping and intelligent design to create a structure system that, while it meets the Cal Poly specs, it's still affordable. A lot of schools, especially if you go back and you look at the 1KCube 2, they're built off chassis that are not necessarily cheap to produce. You can easily blow several $1,000s on your structure. So we want to try and get that down to something more affordable. We also need to design with low power in mind. This is a big one. Solar cells are probably the single largest cost in a CubeSat, and probably in most small-scale satellites. So if we can design a lower power system, this especially applies to COM, because COM is typically one of your largest power hogs, then we can get away with lower efficiency solar cells, which in turn means lower cost. So solar cells are going to be a big cost driver here, and are probably the only area where I'm really concerned about being able to meet this cost estimate. And that's about it. So hopefully we'll have some more later for you guys, but for now, I'm signing off. Thank you very much.